Good morning. This is the SMB3 Landscape and Directions session. We're members of the Windows SMB client and server team. This is myself, Genghis, or Genghis, other pronunciation's fine, and this is Meng. There are other members of the team that contributed to this work, notably Steven Tran, who couldn't present his work today, so we'll cover for him. So again, I'm Genghis, this is Meng. I'll do a portion of the presentation, and then Meng will take over. Roughly, we'll speak about three things: compression and compression sampling, and then two new features we've added to the server, the authentication rate limiter, and to the client and server, the SMB notification. That was an extension to the protocol. Quick overview of SMB3. Recently rewatched our SDC talk from 2017, where it was 5 years old. At this point, it's 10 years old, and quite a few improvements in the past half decade. Signing and encryption, transparent compression. We've added support for new transports, RDMA, or as even Microsoft protocol would describe it as SMBD or SMB Direct. And then most recently, we've added the SMB over quick transport layer. And that was covered in our 2021 talk at this conference. In the past few years, the most notable improvements were compression and compression sampling. Compression was that involved changes to the protocol. Compression sampling is a feature of a client and server itself, and we'll speak about that in detail. And then most notably in the past 2 years, we've added authentication rate limit into the server. And SMB notification, and Meng will speak about those two topics. Just an overview of where we're headed in the future, and this is maybe an open-ended discussion, something we'd like to engage the audience on. Obviously, with SMB being a mature technology, with anything mature, inevitably you enter a phase of optimization, consolidation. You go as lean as possible. If you've attended NetPile's session yesterday, on the security roadmap, you'll see we have quite in mind in terms of deprecating older parts of SMB, and it may be that in the future we'll, deprecate other parts that are no longer needed or have or no longer relevant. And then something very nascent that we're talking and working with partners on is offloading parts of notably encryption and compression into hardware. Any questions thus far? All right, we've covered compression, I think, 2 years ago, also at SDC. I'll just quickly go over what SMB compression is and describe a few interesting issues we've run into as we were implementing compression itself, which may be interesting to other third-party vendors implementing compression. And I know there's at least one here. We've also added support for compression sampling. As I've said in the overview, this is a client feature where we try to determine if compression is worth doing, and I'll describe why we do that, because there is a component to compression where you might not want to do it. That's the cost evaluation and heuristics part, which we'll speak about. And then I'll just quickly go over the performance counters on the client and server to help anybody working with compression to diagnose how well is it performing, is it working at all. All right, just an overview of what compression is. Pretty trivial. We offer seamless data compression at our transport layer. This is something you can enable via policy or on a per file basis. So from the application layer, other than enabling it, there's nothing else to be done. We seamlessly handle compression. If you have encryption on, that will integrate with that as well. It's part of a protocol since version 3.1 and 0.1. Currently, we do not support compression over the RDMA transport. There's no particular reason we do not, other than we simply did not get to it yet. There are some technical burdens on our side that we have to address first. And compression is an area where we see a lot of potential for future expansion. And I have a slide on that as well. And that part, I think, Please engage with us if you have any ideas. There's quite a few things I think we can do. It would help to have input from others to understand, where to focus on. We did cover compression in the 2018 presentation. There's a link below on this slide. Part of that talk described some of the nitty-gritty details of the protocol messaging, but I won't go into those in this talk today. We offer 3 compression algorithms. These are documented by a spec, the MSXCA spec. That's the list on the slide: Express, Express-Huffman, and LZNT1. From the spec itself, quoting verbatim, these algorithms are not designed to compress image, audio, or video data, obviously because that data is already compressed. Compared to other algorithms out there, these algorithms emphasize low CPU cost, obviously at the cost of lower compression ratio. Another thing that we document in the protocol spec, it is also a form of compression. We have a run length encoding prefix scanner that we apply before we run Express. And that simply is we look for a repeating data pattern in front and in the back of the packet that we're transferring. So a few things that are interesting from an implementation point of view for somebody who wants to implement compression. You can, even after you've negotiated compression, again, if you go back to the SDC 2018 talk, we described that in detail. Even after the client and server have negotiated the session and have agreed to enable compression and do compression, you are not obligated to compress every message. Another interesting thing is when the client issues a read to a server, the client specifies a bit that requests the server attempt compression. There's no guarantee that the server will actually compress. It is better to think about this as if the client does not specify this flag, the server will never compress. All right. On the client and server, actually, let me skip over this slide. I'll go into cost evaluation and heuristics first. So compression by itself is maybe costly. It is opportunistic in nature, in that you have to apply a certain amount of effort, but you're not guaranteed to get a reward because you don't know if the input data is compressible or not. Now we do on the client and server employ heuristics on both a macro level and a micro level. On a micro level, we do things such as not compress small messages because even though we may save a byte or two, it's just not worth it. Not only do we expend cycles on the compressor side to do the work, to save that potentially just 1 byte, we then have to burden the server with decompressing that. And just to save 1 byte, that's not worth it. You're not mandated by the protocol to implement these heuristics. A very trivial implementation may simply to always do compression, and that's fine. That could be even something as a reference implementation for testing. And that's on the micro level. On a macro level, we did introduce a feature called compression sampling that tries to evaluate on a larger volume of data if something is compressible or not. So it's a simple state machine. It is configurable. There are 2 knobs. The first is the compression sampling window size, and that specifies the number of bytes that the client will transfer until it makes a decision whether the data stream is compressible or not. The second knob is the goal, is the target. If after transferring that volume of bytes, we've managed to reach the target, we switch to one of 2 states. If we've reached the target, the data stream is compressible, and then for the remainder of the transfer, we'll always compress. If it's not compressible, we do not compress. Another notable thing here is that the state machine runs on the client. It is not the server that is making these decisions. And again, if we go back to this tidbit here about the read operations with a client controlling whether the server will attempt compression or not, we utilize that bit. Yes, if a client determines that the data stream is incompressible, it will never specify that flag to the server, so the server will never compress.
I have a question to that.
Yes, please go ahead.
Would the client, if it, for example, splits the read into, let's say, 108 megabyte chunks, and let's say 10, will it then also run this algorithm on the received data in order to check if the other 80 requests should be compressed or not?
So I'll repeat the question and then just verify that I interpreted it correctly. So if somebody sets for the first knob, the compression sampling window size to 100 megabytes, and the client only completes a portion of that data transfer, let's say 10 megabytes, does the sampling state machine make a decision or not?
No, my question was if this sampling also happens on reads, where the client gets data from the server in order to specify that after it decides that it's not worth compressing, the remaining requests don't have this bit set.
Okay, so your question was for reads, when the client reads back data from the server, and the server responds back with obviously a compressed packet, does the client does the client consider that as part of the decision? Yes, it does. Obviously, again, there's a caveat here in that we'll specify the bit, as part of that, while we're in that evaluation phase, we'll specify the bit to say, server, please always compress. The server will compress. And I believe actually, so remember earlier I mentioned that small messages are not compressed. In that case, I believe, I'll have to double check the code, that the server will still compress. So the server may do useless work here. But when that packet comes back to the client and the client decompresses, it will compare the size of the decompressed buffer and the size of the compressed buffer and then consider that decision, yes. And you do have to transfer the full target size, the full volume, before you transition out of the evaluation state into either the compressible state or the not compressible state. So those are terminal states. Once you're in one of those two states, you never come out of those until the file is closed.
Does the server do an evaluation as well?
The server does not. Actually, when I studied the code originally, that was surprising to me. Perhaps there is a different design here where the server may do the evaluation and coordinate with a client.
Because then it could be sort of opt-in rather than opt-out, rather than starting the request and turning it off if it's worthless. The server could say, well, I can see it's not compressible, so I'm not going to compress.
All right. So, yeah, sorry. Yeah, the question comment was, can we do the sampling on the server? Can the server cooperate with the client on doing the sampling? I believe so. I believe there is a design that will work just as well, or maybe even slightly better in some regards. We have to do some thinking on that. But ultimately, even if you do it just on the client, just on one node, the client ultimately receives a packet back from the server. So we'll do the decompression. Yes, if you did that on the server, perhaps the server may avoid doing costly compression work that it would perhaps know ahead of time that this is not compressible, let's not do this.
The server also sets the response as compressed?
The question was, does the server send the response as compressed? While we're in that initial evaluation state, the client will ask the server to compress all the time, yes.
It's always expected as server will compress.
Is it expected that the server will compress while we're in that initial state? Yes. Yes.
This is only for data operations. Data operations are by default not compressed. On client side.
Sorry, which other operations are within data?
The sampling is done only for reads and writes or for metadata operations also?
Good question. I believe we only do it, the question was, is the sampling done only for reads and writes or other messages such as metadata? I believe it is only reads and writes, but I'll have to clarify and get back to you on that. These are the knobs here on the slide that control compressibility sampling through our PowerShell interface, set SMB client configuration. There's a knob to enable, disable it, a Boolean option, and then the compressibility sampling size and threshold. Threshold is that target value. So let's say you specify compressibility sampling size to 100 megabytes, compressible threshold to 50 megabytes. For the state machine to determine that the data is compressible, those 100 megabytes have to compress to at least 50 megabytes. So 49, 48, 50, that's fine. That's considered compressible. Anything over 50 is not compressible. And Ned recently published an article documenting all this. There's a link here. Since this is not a protocol feature and something we've added fairly recently, obviously there'll be some probably defects or shortcomings we find, so this is subject to change in the future. I've covered this earlier. I've skipped to the slide again. So compression, just to summarize, compression, the gist of it. The compression is an opportunistic operation. It may be costly with no guarantee of a reward. Therefore, it would make sense to add some smartness around whether we do compression or not. In terms of diagnostics, we've added several performance counters on the client, on the server as well, I believe, but the client ones are more detailed. There's the compressed request per second and compressed response per second that track the number of compressed requests and responses. Again, I'll double check if those just include read writes or metadata as well. And then for cases, again, I mentioned that we will not always compress due to heuristics. For cases where we fail compression or decide not to compress, those requests will not be counted in the successful compressed requests per second. So actual number of packets compressed is that last counter, successful compressed requests per second. You can, again, monitor these counters using the built-in Windows Performance Monitor. A few screenshots here. So two different workloads. One is we're just writing data that's completely random, pseudo-random, and it's not compressing at all. You can see the successful compressed request per second counter is 0. Writing all zeros continuously. A surprising thing here is we should be able to compress every packet, but we do not. And I believe that goes back to the gentleman's question. Perhaps we're not compressing metadata packets. So I'll go back to that and double check, and we'll document that. And on this slide, I'd like to call to the audience and other vendors out there who are implementing compression. Again, I know there is at least one. We've had plenty of questions, found shortcomings in the protocol spec that we've addressed, and there are a few other paragraphs we'll need to address there as well. On our roadmap, definitely we need to add compression support for the RDMA SMB direct transport layer. In the way that compression combines with encryption and signing, specific to our own SMB client and server, we want to do a bunch of refactor and address technical debt. And partly that is the debt that is preventing us from committing to implementing compression with RDMA and SMB direct fast enough. Another thing is we'd like to add more sophistication to the compression cost evaluator and heuristics. Automated performance analysis, for example, which algorithm performs better or not versus others. Which ones are more CPU heavy versus higher compression ratio, which ones have a higher memory footprint. And again, you might have different characteristics on the compressor and decompressor. SMB compression, in the past few years, we've had a few security cases, so this is obviously one of the more complex portions of our code. And again, just generally anything with higher complexity, higher risk of defects, especially security defects, and our implementation living in kernel mode, those can be especially dangerous. We're onboarding automated fuzzing for the compression layer. That's not done yet, but that's in progress. Interoperability validation. So if we extend this going into the future, this being a complex part of a protocol, we'd like to make sure we interoperate not only with older versions of our own client and server implementation, but also third-party vendors out there. So I'd love to have a discussion with other vendors out there if we can set something up where we run something on a semi-automated basis. I don't know, some cloud somewhere, we rent VMs, and we run different clients against our own client. That'd be just great. And again, I've mentioned in the overview slides, something very nascent we're working with hardware partners on is offloading compression into hardware. That's not something that's standardized at all. I think we'll see standardization in years' time at least. And other than the 3 algorithms that we currently support, I'd love to open this up to other compression algorithms out there. I know there's been quite a few developments out there in the open source world. C standard one is a notable one. So if we can support that, well, you know, being compliant, that'd be great. Another thing I'd like to do, we were thinking of, is extend the protocol to chain different algorithms together. So as an example, the RAR compressor, WinRAR, it implements filters for better compression, more efficient compression of executables. The way it does that, it runs filters that flatten branches in executable code, and that just makes, that increases the opportunity for redundancy. So if we can do something similar, actually in the MSCAP format, we do something similar. If we can stick that into SMB, somebody copy the exe files, you know, they'll benefit. A few links on this slide. Again, there's that article that we recently published, and then the spec link for the express compression algorithms.
Quick question.
Yes.
So, for your various compression algorithms, it's very handy to have a set of files, predefined files, and then compress them into 3 algorithms, and then have the output files of what the compression should be. Because each company has to write their own implementation of those compression algorithms, and they need some way of verifying that their algorithms are correct.
So I think just to summarize the question, it's on the correctness of implementation of these compression algorithms. Yeah, I'm not an expert. I'll have to look into that and get back to you. I don't believe we have a reference implementation. We should. At this point, I'll hand off to Meng. It's 8:52. Yes.
Question. If the client requests compression, is the server allowed to reply uncompressed?
The question is, if a client requests compression, is the server allowed to reply uncompressed? The answer is yes. Again, there's that bit, SMB2 read flag request compress.
That's request. So if the client requests compressed, can the server reply uncompressed?
Do you mean if a server sends something uncompressed?
The request is compressed, can you fail the request if you don't? Is that?
So the answer is the server can always reply uncompressed. Yeah, it's a hint or a please kind of a bit. It says controls. Controls is a little bit strong, but it requests the server to attempt compression. And the server can say, sorry, it's not working, and reply with a normal reply.
Can the server select which compression algorithm to use for the reply?
In fact, it always does that. Yeah, there's a set of algorithms that are agreed upon by both client and server.
Right.
I'm sorry to jump in.
No, thank you, Tom. Yeah.
This is tough.
I appreciate that, yeah.
I used to be with Microsoft, but I'm the author of some of these documents. It basically, they pre-negotiate a list of algorithms, and they can choose whatever algorithm they like to make a request.
It's just like how they negotiate the ceiling algorithm. So the client sends a list, and then the negotiate response, the server picks one. So this is the one we're using.
So it's not on a per request basis. The server can't say, well, the state is paid.
No, the algorithm never flows over the wire explicitly, except in the very beginning when it agrees which ones. It's more than one, right? I mean,
The server will only pick one.
Well,
except for the
each
fact-
operation uses only one, correct, but you can try multiple algorithms and see which one's best and choose that one for the block.
The server returns one algorithm. One of those, LZ, whatever, it doesn't return back a list. It would be nice if it would.
Yeah, because different streams make requests payable with different algorithms.
So follow up on that. So, and it's done only at a per connection level, and there's nothing at shared level you can do.
What do you mean by it?
Some machines negotiated as part of negotiate request on a connection basis, and for the whole connection, for all shares access to that connection, it sticks lifetime of the connection.
The question is at what level or what grain compression is negotiated. Yeah, it's at the tree connect session setup, I believe. So I'll refer to the SDC2018 talk. Some of these messages and session setup negotiation is described in detail there at about 33 minutes in. All right, at this point, I'll hand off to Meng. Thank you.
Thank Genghis. So let's move on to SMB authentication rate limiter. So which is a new feature developed to defend against NTL password brute force attacks. We have future plan to address the parallel password spray attacks. To recap, in SMB we have SMB server or serve2 instance. Each serve2 instance will handle traffic from from regular SMB client accessing file shares and other like internal traffic. And we also have other serve2 instance for example, CSV and SBL. So let's move on to the structured design of the authentication rate limiter feature. So each serve2 instance have a timer wheel. And in the so the reason we have only one time wheel is that we want to ensure we are not relying on like just one wheel for our serve2 instance. So each wheel will have a structure like containing various members. For example, the slot array, so which is an array of slot which is actually a linked list, contains all the delayed authentication work item. And we also have a cursor which pointing to where we are in the slot array. And we have an expiry counter, so which counts how many expiry have so far in the implementation. So for example, if we have the count is equal to the number of the total slots, so it means that there is nothing to process, and we can turn off the timer to save the resources. And also we have the DPC we can use this to process the delayed authentication work item. So this structure is per NUMA node. To recap, the NUMA or non-uniform memory access is a computer memory design in multiprocessing. So so this means that the memory access time will depend on the memory location relative to the processor. So a processor can have access to this local memory faster than non-local memory. So the non-local memory could include memory shared between processors and memory local to another processor. So the reason why we make the authentication rate limiter per NUMA node is that if we just rely on one slot array for all NUMA nodes, so this will cause performance degradation, which will cause some inter-node or cross-node memory access, which will increase the memory access time. So for example, if we have a machine of 2 NUMA nodes, we'll have something like in the diagram. Each NUMA node will have a structure, similar structure. And each slot array is, as I said, is an array of linked list, which contains the delayed work item. So in our current implementation, we allow the authentication delay up to 10 seconds. So in order to accommodate this amount of time delay, we have to ensure we have enough time slots to do so. So in the timer, we will have a timer expire every 100 milliseconds. So if we use 10 seconds divided by 100 milliseconds, it's equal to 100. So that means we would have 100 time slots from index 0 up to 99. So whenever the time clock ticks, we will process all the delayed work item in the linked list for each index. So let's look at the example. So this is a simplified example to examine how it works. So we assume the cursor is pointing to the start of time array, which is index 0, and we assume the time between the time slot is 1 second, and we want to delay the work item for 2 seconds. So this means that when the work item arrived, we will schedule 2 nodes from the starting cursor. So after 1 second, the cursor moves to next index, but there is nothing to process. So we keep moving for next second. So the cursor is pointing to index 2. So it will grab all the work items in the linked list from index 2. It will process by the SMB server. So there's other improvement to make this work correctly, because in SMB, there's some dependency on the SMB. For example, the multi-UNC provider and the distributed file system. So for example, when we use the net use, when we access the net use, the server share with username with invalid password, there will be some dependency cause the delay. For example, DFS will attempt SMB3 connect to the dollars and IPC share to check if the path is part of the DFS namespace. This happens before the SMB client try to do a regular SMB3 connect. To resolve this additional delay, so we have added a new, an active cache. So there will be a 50% improvement over the net use case. So there will be only 1 trip instead of 2. And 75% improve over the correct cases. There will be only 1 trip instead of 4 trips. Any questions for? Yes.
So it's implemented within this server, and there is no protocol extension to this, right, in terms of error codes or anything like that.
Sorry, can you say it again?
Is there anything extended over the SMB protocol to make use of this?
Oh, this is enabled by default. So there's no extra implementation on this.
Even on the wire, you don't see any new error codes or anything like that for your network or request or something like that.
It's a server feature, not
Okay.
a protocol.
So let's move on to the SMB notification. So it's a one-way server to client message that became repurposed to replace the scale out file system witness mechanism, and the client periodically querying the available network interface on the server. So this was originally designed to solve the remote desktop services, the terminal services, auto disconnect timeout issue when the SMB encryption is turned on. So this happens, for example, we have multiple users accessing a share. One of the users have idle for more than 50 minutes, which is a default in our current implementation. So the server, in order to save the resources, it will forgot encryption, decryption keys, but the client doesn't. So after next time, the user issue another IO request using the same session. If the session is valid, So it will issue the request to the server, but server cannot decrypt the message because it already got the decryption keys. So it will send the error message back to the client. But the client expects a valid response with a valid message ID. So it will terminate the connection, cause a TCP session reset. So what we have done is let the SMB server send a session close notification to the client. So tell the client to disconnect that session, matching the session ID. So whenever the next IO trigger the session re-establishment, it will kick in the existing reader state machine. It will create a new session with new encryption and decryption keys. So here's the overview on the protocol change. We have the SMB server to client notification message. We have a structure size 2 bytes, which is the size of server to client notification message. And we have a reserved 2 bytes for future usage. And the notification type is the server to client notification. We have 4 bytes. For the notification, because we only support this notification, so n is equal to 4 over here. And the bottom one is for the SMB to notify session close message, which is 4 bytes. So here's the update on header. So this feature will have a new header command, SMB to server to client notification with this new value. So the new client will accept SMB uplog break and SMB server to client notification when the message ID is this value, which is an invalid message ID. So for the client can receive a session close notification anytime when after the user have issued a session setup request to the time the client received SMB response to the client log off request. So for the same session. So if the client cannot find the existing session in the connection session table, the client must discard the notification.
So the server can just close sessions, and when would it do it? When current tickets expire, for example, or?
Oh, so we have some way to do the notification. I will talk about in the slide later on. Yeah.
So there's no reply to the notification, right? It just dropped the message.
No, the server doesn't expect reply from the client.
Okay, so it's a one-way.
It is one-way.
notification.
Yes. Yeah.
Okay.
What's different from user session deleted response on the client side? Normally, once the session is closed, post that if client sends response, it can send the session user deleted. There is anything next to it.
Sorry.
So the question was, how different is it from a user session deleted response from the server?
Yes.
So Tom, correct me if I'm wrong. User session delete is a response from a server. The client will have to send something first to get a response. Whereas this mechanism, the server out of the blue can send something to the client unprovoked.
So just trying to understand the motivation for this, right? So is it to correct the client behavior? Because you mentioned client remembers the signed and encryption keys, which it doesn't invalidate if the and keep on retrying with that. Are we trying to fix that issue with this? So just to add to what Henry was asking, right? What if you just did nothing and client sent a SMB to create or something with that invalid session ID, you respond to that with session deleted. What would client do differently than when you send this out of the band notification?
Question was how different Do we have to do this? Because if we did not, the client would eventually get to a state along with the server where, yes, the session is invalid, but they would renegotiate, reconnect, and then everything will be good. I believe, yeah, that's what will happen. I don't think we have a slide on the original context of the problem we're trying to solve, but that's essentially what was happening. There might have been something more serious to that problem we were solving. I don't quite recall.
Last question. And this is implemented in a specific version of Windows client, so the specific version?
It would be the latest one. I can't recall off the top of my head. The question was what version? Something fairly recent.
Okay. And there's no plan to backport it to the.
I believe we backported it to some slightly older version. We'll publish those details.
You haven't, maybe you're going to say this, but you haven't yet said what the client does if it does find the session. Are you going to, what's the client action on this notification? Are you going to talk about that in a minute?
Oh, yeah. Genghis, are we gonna?
Sorry.
The question is, what does the client actually do? It says here it discards the notification if there's no session. What does it do if there is a session? I'm assuming it's being requested to close the session.
Right, so the client will close the session.
And so the server will give him a little more time, and if he doesn't, he just slams the door and does what it does today.
Right, so this is a mechanism to more gracefully notify the client that they should
Okay,
reset
so-
the session.
General client information, if it does find the session, please close it, right? That's the action that's being requested
Yes.
by this callback?
And that gives the client the opportunity to flush buffer and so on.
Like an uplike break would be.
Well, because the server is essentially saying the keys you're holding, the state you're holding is now outdated. I'm going to discard it on my end, on the server.
Yeah, but it's
Just the keys.
It's not a notification that it's already closed, but it's a notification I will close in half a minute or so.
I mean, I have also 500 on that session possibly. With outstanding rights, due to your cost. What do we do with them? Throw away?
Even the early side, it said it was a notification. On the early side, it said it was a notification that the session had been closed by the server.
So my delayed write updates are gone. Right?
Is that right?
I don't know. We'll have to.
Or can I just recode or recover it, for example, and then continue writing? I mean, is that really gone in the sense of gone? Or can I revalidate that somehow?
So I believe your question is, what do we do with outstanding operations
Yeah.
as we're.
Or I mean, even I have buffers that are updated because I have an exclusive lease. I want to write later on, but my session is gone. Data loss.
Right, those are good questions. Unfortunately, I don't have an answer. We'll get back to you with the answers. We'll ask
I guess
Steve.
you had a slide which said it's used for idle session time or closure from server side. I thought that's the whole context, but it looks like it's not. It can close it even if you have a valid file handles on that.
So yeah, the motivation was there was a server knob to automatically retire sessions. And when the server did that, it got the client into an undesirable state. So that was the motivation for doing that, is to gracefully tell the client that the server is doing that, client, please do be aware of that so we don't go into.
But we would only do that if the session was idle, you had no outstanding handles, etc. Because if you have outstanding handles, then
Correct, but then there's always a race with the server switching the session to the state where it believes it's idle
Yes.
concurrently with
It's part of
some request coming in that unidles it.
yeah. So this is a trigger when you've got an idle session and you're telling the client, hey, if you don't do anything, if I don't see anything from you in a little while, I'm going to close this.
Yeah, that's the question. Or is it a, hey, I already did it?
Yeah, that's the real key. Because we have something similar in idle connection time where we have no handles and we don't see anything for a little while. We'll just close it. It would be nice to get this message notified in that case.
Uh,
If there's something which is better.
We'll have to double check. I think I understand the concern. Yeah, is it how idle is it, and if a client is really not that idle, what happens with the state? Is it? So this is something we've recently added. We've never, well, we've had something where the server tells the client, but I'll imagine we'll find issues. So this could be one way.
Okay. So in terms of the integration dialect, we have a new SMB2 global cap notification. So it will indicate the SMB client can receive such notification from the server. So the client will send this new global flag along with other capabilities. So the server must set the support notification, the connection support notification to true if the capabilities agreed between the client and server. So during the initial session setup, the session support notification must set be true if connection support notification is true for that session. In case of SMB multi-channel, for subsequent binding request, the server must check against session support notification with connection support notification. So if the value is different, the server must reject the binding request from the incoming client. For the signing, we have some idea to implement this. One solution is to add a new server notification bit set to 1 for AES GMAC noise generation. So this would require us to generate a random 64-bit message ID for each notification instead of the current invalid message ID. The other one is to add a new field to serve to client notification structure to send a randomly generated noise by the server. So for clients larger than 3.x, so it will acknowledge receiving SMB with random mate. For server larger than 3.x, so it will send the signed notifications.
So you're using a random mid to avoid resending the same payload twice. It's serving a little bit like a nonce, I think. That's odd, but okay.
Yeah, I don't have any detail on this one because this we haven't implemented this yet.
Oh, okay.
Yeah.
The random mid is what gets me. I don't quite understand that. I'd like more detail, but okay.
So for the protocol change, when the SMB encryption is turned on, so there's two scenarios to handle. So if the notification is not associated with SMB session, the encryption will not work unless we broadcast the notification to all clients, to all sessions in order to use the encryption key. So other case, if the notification is associated with a specific SMB session, so the notification will be encrypted and sent to the client. So for multi-channel scenario, if the notification is not associated with specific session and scope to some client, so the server will iterate through the client connection list, matching the GUID ID for the client to send the notification to first available connection. If it failed, it will try next connection. So if the notification is associated with a specific session, so the server will iterate through the session channel list to find the first available connection. If it failed, it will try next connection.
Is this specific to this request? Why wouldn't it do the same thing that oplock break does?
For the oplock?
Well, it's very much like an oplock break. Does oplock break iterate through all the multi-channel connections?
Yes. So we try the first one, and if that doesn't go through, it falls back to the next one. If you believe it or not.
Well, but doesn't go through implies that there's a response that times out, but yet this operation could take quite some time to notify all your channels if you're going to wait for a timeout on every one of them.
Right.
That's odd. I just wonder why it doesn't follow the behavior of an off-block break. I thought an off-block break was only sent once.
Okay.
It's a notification, you get one chance, if it didn't go through, well, you know.
No, for users, every channel, right?
An off-block break doesn't have to be responded to.
Okay.
If it's a write-off block, but if it's a read-off block, it doesn't require a response. I don't know, never mind.
Okay, thank you. So here's example of the SMB notification. So we have the SMB header, SMB to server to client notification. We can have the structure size, notification type, notification, and SMB to notify session close message. So there's some practical usage to trigger this notification. One example is use the close SMB session with a session 90. The other example is to have 0 open file handles on an active session when the encryption is turned on for the SMB share. So we can let the session idle for until past 15 minutes timeout, so which is default in our current system. So the SMB server will clean up the state for the session and send the session close notification to the client. So when we implement this session close notification, so give us a easy way to reproduce a rare exchange deadlock due to the network disconnect in SMB director, which was also fixed recently. So in the next version of Windows Server, there will be a new command for get set SMB server configuration auto disconnect timeout v2. So there's some confusion in our current Windows Server. We use the auto disconnect timeout for SMB version 1. So in order to fix this, in next version of Windows, we're going to use auto disconnect timeout version 1 to distinguish this. Yeah. Thank you. Thank you all for attending this session. That's all.